I guess all of you know the concept of linked list, so I will just say what are the required things. Okay, so basically, what till now what we did is, okay, should select till now what we did is we took array. We will just write 1, 2, 3, 4, and 5. What we did is we took an array, and it is a continuous memory location where we will store the memories. But what's the problem here is, as it is a continuous memory location, there's if you want to add an element, if you want to delete an element from an array, that would take the time complexity more, and it would be heavy to manage when there are large amount of data. Assume this the data is in billions. Okay, at that time, if you delete an array, if you delete an element, suppose you are deleting 3 from an array, what you have to do, you have to shift the corresponding forks and fry one step back to make it continuous. This was the step which we want to do in array. Assume you are having a data of 2 billion datas. At that time, if you want to delete the 100th or 1000th element, at that time you have see how many elements you have to shift it. So that would be the tedious task. That's why what they had in, they needed a data structure which is not continuous, which is non-linear. Suppose, so assume we are having 1 here, 2 here, 3 here, 4 here. Previously, we need to take these elements and put it in a continuous memory location. Now what we can do is, we can keep the elements there itself in the memory and just have a reference of what elements comes next. 1 2 comes after 1, and after 2 3 will come, and after 3 4 will come. What we can do, we can just refer what comes next by linking it. Okay, here you can see what we are doing. We are referring the next element by just linking it. This is the same procedure what we can do in linked list. In linked list, what we will do is, linked list is made up of node. Okay, so what is node? This is a name given to a structure. uh, Guys, everyone knows struct, right? Self-referential, what's the name, like if you get a structure, it will okay, why do we need structure is, in array, as you can see that we should store only the same data types element. If you are storing numbers, use defined user defined data structure. Yes, user defined data structure. So that's what in array what we have to store. If we are storing 1 2 3 4, we should store only 1 2 3 4. If we are storing abcd, we should store only abcd, because of its homogeneous characteristic. But to when in real world cases, what will happen, we need a data structure where we can store the different types of data types. For that, user defined data structure, one of the user defined data structure is what we can use is struct. So I would not say I would not waste my time by saying the syntax of writing this thing. Just okay, guys. I would just want to say, if you guys don't know any basics related to this, go to YouTube, see Nisso Academy or Apna College. They have done a very good example video or definitely like video regarding this linked list, where you will get the concept of linked list. Okay, this boot camp is all about solving questions related to linked list, not explaining what linked list is. So I will just directly jump to the main part, which is a node. In node, what we are doing is, we are having two places. First, where we will store the data, and second place we will store the link. As you can see in this example, we have 1, and then 1 is reference to next element, which is 2. 2 is reference to next element, which is 3. Like this. Here, what are the things we have? 1, which is a data. We can call 1 as our data. Next, what it is doing, it is referencing to 2. So here we are referencing that to 2. What's happening in 2? 2 is referencing us to 3. What's happening in 3? 3 is referencing us to 4. What's happening in 4? 4 is in 4, we can say it is not referencing to anyone. So we can say that it has null element. So you guys got the concept. Let me just draw again. We can write 1, it is referencing to next element, which is 2, which is referencing us to next element, which is 3, which is referencing us to the last element, which is 4. This is not referencing to any element, that's why it contains null. So we can say a node is a structure which contains, which have two parts. One is data, one is link. Okay, and in reference to this bootcamp, for data we will sometimes say data or sometimes say value. This both things are same. And for link we sometimes say link, sometimes say next. These two things are same, data and value are same, because in LeetCode also for few problems they have mentioned data and value, for few problems they have mentioned link and next, as far I have researched it. Okay, now you got to know if 1 2 3 4 is stored in array, it will be stored like this: 1 2 3 4. In linked list it will be in this format. And one more thing guys, if you can see, I have said 1 is referencing to 2, 2 is referencing to 3, but how it will know that 2 is here only, 3 is here only? It will know that because of the memory location. Here suppose this memory location is 100, this is 200, this is 300, or this is 350. Here, like, take it to 290. The thing what I want to say is these are not continuous memory locations, or just like there's no gap like 100 also, and it's not like continuous memory location also. These are randomly located memory locations. Here you can see 2 is stored in location 290. Okay, so what will 1 do? What's the next element of 1? 2. What it will do? It will refer to the location 290. So we in struct node, in this node we are having one data and one link. What is data? Data is an integer type. But what is link? Link is not an integer type. Here you can say 290. 290 is an integer. But this 290, we just took an example as a memory location. So this is what, in basically this is a location, or we can say address. So to store address, there's one data structure called pointer. There is one concept called pointer. What is pointer states? In pointer is a variable in which it can store address of another variable. So guys, what's the definition of pointer? Pointer is a variable which can store the address of another variable. So in node, what we have data and we have link, where data would be our integer, and most of the cases it would be integer, but depending upon our question we can change it. So basically data is the value which we are storing, and link would be referencing to some other node. This is node 1 and this is node 2, and this is called a linked list. Okay, a node will contain a value and a reference. We can call it reference, we can call it something. This is a pointer. Okay, what it has a address of next node. So a pointer is a variable which can store the address of another variable. So in this case, what it is storing, what this pointer is storing, this pointer is storing the address of next node. What this pointer will be storing, it will be storing the address of the following node. Okay, so when here if we go 290, which will be the address of this node, then this would be referencing to this node. Suppose this address is 300 and we change this 290 to 300, then what will happen? This connection would be break, and this is connected to, this is being referenced to this node. So if you understood this, that is well and good. If you didn't understood this would, now let's see our next thing, how to, here we see how we can write 1 2 3 4 in linked list. Okay, now we will see if you want to add an element or delete an element, how it is done. Okay, so in Java or in any DSA, what we will do is one, let's take, we have just written 1 2 3 for now. We are having a linked list called LL, and it is storing 1 2 3. The addresses are 100, 150 and 250 for our reference. So can anyone say what would be written here? $150, because I have shown the reference between these two nodes. Then here, as I have shown the reference between these two nodes, 250 will be written. Here it will be not referencing to nothing because I have written into mark. Here in our bootcamp, into mark means null. Okay, just for reference. Now, how we if we would need this element, we can get this element using this pointer. If we need this element, we can get this element by using this pointer. So basically, where does it start? It starts from here. So how we will get this one? We need something to access this one, right? So we will use a pointer called head. Head is a pointer which we usually use in our DSA. Okay, this is a pointer which would be pointing to our first element of a linked list. So this is a basic structure of a linked list. Okay, this is a basic structure of a linked list. Assume the name of a linked list is LL, the address of a first node is 100. And can anyone say what would be stored in this pointer? What's the value stored in this pointer?
You are asking what is stored in head variable or
Yes, what is stored in head variable?
100.
Yes, exactly. So guys, the one thing which beginners need to know is head is not a node. This is a node. Consists no, Node consists of data and pointer. Okay, but here head is only a pointer. What's the significance of head? Head always shows us the first element of a linked list. So now when in an input, if they will be given a linked list, then they would be mentioning head. Okay, they would be providing us head. By using head, we will get the first element. If we need our second element, what we can do? It's similar. If you guys know the structure, means struct keyword, you will get to know. So suppose I'm writing a struct and I'm using node as an example. Here what we are having data. This is a semicolon. We are having data and we are having a pointer. So guys, the syntax will always will be provided in the notes. Okay, so basically there's a structure called node and it contains data and pointer. If we need to access these things, how we will access?